Okay, so this video is going to be for our first assignment from section 2.1 quadratic functions on page 96. So I've got my page and my problem numbers written out, so let's get started. Let's see, fix my camera a little bit. Alright, so in number 23, the directions are to describe the graph of the function and identify the vertex. So there's two ways to do all of these problems, but I'm going to model this after example 3 and get it into vertex form, or maybe example 2. So if h of x is x squared minus 8x plus 16, the method is to use completing the square, which this is already a perfect square trinomial. How do I know that? Because my first term is a perfect square, my last term is a perfect square. The square root of 16 is 4 or negative 4, and if I double that, then I get my middle term. So I can just factor that without hardly any trouble at all, and I get x minus 4 squared. So this is in HK form. It just so happens that my k happens to be 0. There's no a value out in front. So to describe the graph, it's a standard opening parabola and it's 4 units to the right. And it's not shifted up or down, and it's not stretched or compressed. So I could probably just go like this and sketch the graph. That's a pretty good description, and then I'm supposed to identify the vertex. So the vertex is going to be at HK. In number 25, the directions are the same. So f of x equals x squared minus x plus 5/4. So I can already tell that that's not a perfect square trinomial because 5/4 isn't a perfect square. So you can see when I copy the problem, I'm leaving myself some room to add something to complete the square, and then if I add it there, I'm going to subtract it there. If I subtract it there, I'm going to add it there. But with a perfect square trinomial, I'm always adding something here. So we need to know what to add. So I need to know what is going to be a perfect square that when I square root it, it's going to make this number doubled right here. So right now I've got a 1 there, and half of 1 is a half, and a half squared is a 1/4. So a 1/4 is a perfect square. The square root of it is a half, doubled, and that is, or the square root of it is negative a half, and so doubled, that equals -1. So I added a 1/4, and now I'm going to subtract a 1/4. And so when I factor my perfect square trinomial, that's going to be x minus a half squared. 5/4 minus a 1/4 is 1. So now I've got my parabola in HK form, and my vertex is going to be h comma k, and that is 1/2 comma 1. So that's where the vertex is located, and it is a standard opening parabola. And even though the directions say use a graphing utility to verify, if you guys are not sure, you can plug in the original equation and you can graph it, and you can double check that that's where the vertex is. I'm fairly certain, so I am not going to do that. And I don't have my graphing calculator anyway, so that is not possible right now. So in number 29, this is our first one where we see a leading coefficient. And so I'm just going to copy the problem because I know I've got to move this 21 over, and I want to factor out this 4 so that I end up with a leading coefficient of just 1. So after I factor out a 4, I get x squared minus x. I'm going to leave a space. Then I have my plus 21, and then I'm going to leave a space. So this is going to be very similar to the last problem where my coefficient right here is 1. I can take half of 1, which is a half, and then square it, and I get a fourth. So the only difference is that fourth is truly multiplied by 4. So 4 times a fourth is 1. So I added 1, so I actually need to take away 1 whole. So as I am factoring this, plus 21 minus 1, so that's plus 20. So now my vertex, I have an H, I have a K, and I have an A value. So this has a vertical stretch, and so it has a vertical stretch, yeah. So number 31, we have a new set of directions, so let me go ahead, I'll copy down the function and let me check what I'm supposed to do with it. X squared plus 2x minus 3. So we're going to identify the x-intercepts, describe the graph, identify the vertex, and use a graphing utility to verify. Okay, so first thing I want to do is get this thing, well, I could go ahead and factor it. So I'm looking for something that multiplies to be negative 3 and adds to be 2. So that would be a positive 3 and a negative 1. So let me go ahead and write that out. And so I can identify my x-intercepts, negative 3 and positive 1. Then let me go ahead and get it into factored form by completing the square. So I'll do negative x squared plus 2x, and then I'll leave a space. Then I've got my minus 3 out there and another space. So to complete the square, cut this in half. 2 divided by 2 is 1. 1 squared is 1. So the only issue is I have this negative out here. So even though I added 1 here, it's a negative 1. So then over here I actually need to have a positive 1. So now I'm ready to complete the square. Negative x plus 1 squared minus 3 plus 1 ends up being minus 2. So describing this graph, it has a vertex at 1, negative 2, and it is flipped over the x-axis. So that's it. Now this vertex 1, negative 2, so if you picture this graph, I have intercepts at negative 3. Let's see, let me get a better view of that. I have an intercept at negative 3, 0 and 1, 0, and it's upside down. So okay, so this is a way to check. 1, negative 2 is down here. So this absolutely does not make sense for my vertex to be here and my x-intercepts to be here. I'm expecting it to be at negative 1, positive 2. So what did I do wrong? This is good for you guys to do error analysis. So here's what I did wrong. This negative was with this 3 the whole time. So this was a positive 3, and positive 3 plus 1 is 4, plus 4. And what about this guy? X plus 1 squared gives me a plus 2x. Oh, so my vertex, if this is plus 1, remember it's x minus h, so a plus 1 means it's x minus minus 1. So my h is negative 1, and my k is plus 4. So 1, 4 is up here, and if that's a downward opening parabola, it's right in the middle of my two x intercepts. So now that makes more sense. So visualizing the graph actually helped me find a mistake. In number 37, we've got a picture of a parabola and we want to write the equation of the parabola. So it's interesting that, so we have our vertex is at -1, 4, our y-intercepts are -3, 0, and 1, 0. So unfortunately I noticed that is the exact same as the last problem. So it doesn't take me any effort at all to write that equation since I noticed that. But if I didn't notice that, I could go ahead and substitute my h and k. So I would go x minus 1 is +1 squared, and then +4. And then in order to find what my a value is, I would need to pick a point and substitute it in. So I'm going to pick one of the x-intercepts. I'll just do, well, I'll do the one that doesn't have any negative signs. That's easier for me. So I'll substitute x and y. And remember that f of x is the same as y. So I could go 0 equals a times 1 plus 1 squared plus 4. So 1 plus 1 is 2, squared is 4. So 0 equals a times 4 plus 4. Okay, so that's -4 equals 4a, so a is -1. So that's how I know that I end up with a negative sign out in front. There we go. So this was one form, and then this is HK form of that equation. Let's look on at number 39. Let me label this with the section number. So number 39 is going to be, adjust my camera. Alright, 39. We're given the vertex and a point. So in number 39 it's -2, 5, and the point is 0, 9. So I'm basically going to do the same thing I did in the last problem, and I'm going to write out my equation, and I'm going to substitute my h and my k. So minus 2 is +2, and then +5. And then I'm going to substitute my point so that I can go back and find a. So 0 plus 2 squared plus 5, 9 equals, so 2 squared is 4, 4a plus 5, minus 5, minus 5, 4 equals 4a, so a equals 1. So since a is 1, my full equation of my parabola is just x plus 2 squared plus 5. In number 43, you are going to do the same thing. You're given the vertex is 1/2, 1, and your point is -2, -21/5. Is that right? -21/5. Okay, so let's go ahead and I'm just doing things one at a time. Y equals x minus 1/2 squared plus 1. And then I'm going to go ahead and substitute my y. -21/5 equals a times -2 minus 1/2 squared plus 1. So, working out the math, we go. Negative 21/5 equals a times negative 2 minus a half is negative 5/2. And let me find out what that would be as a coefficient. Square the top, square the bottom, subtract 1. So this is a super messy fraction problem. Normally they work out a little better than this, but I guess it's pre-calculus, so we don't have to worry about that. So subtract 1, subtract 1. Now 1 is the same as 5/5. So negative 21 minus 5 is negative 26. And to get a by itself, I'm going to multiply by 4 over 25 on both sides. So we get a equals, and nothing cancels, so 4 times negative 26 is negative 104 over 125. So our final answer, sorry, there's my math for that. Our final answer then is going to be f of x equals negative 104 1/25 times x minus a half squared plus 1, and that one makes me really doubt myself, so I'm going to go to the back of the book, just like you should, and I'm going to find section 2.1, and I'm going to check my answer. Every other one I was fairly confident, but when I get a big messy one like that, it makes me want to check my answer. And boom, I'm exactly right. So, no worries. Alright, number 45. We have a picture that's given. So, I guess the graph should be able to look there and see what the intercepts are. So let me just write down the problem real quick. We get y equals x squared minus 4x minus 5. And the picture, it looks like the intercepts are negative 1, 0, and positive 5, 0. So if I factor this, I should get negative 5 and positive 1. And that's what I get. Negative 5x plus 1x is negative 4x. So that's the factored form. So that makes sense that those would be the intercepts. Then find them algebraically. Okay, so that's what I just did there. So I'm done with that. And number 49 is the last one. And we are given the function x squared minus 4x. And what are we supposed to do with it? We are supposed to graph it, find the x-intercepts, and then find them algebraically. So I'm going to leave the graphing up to you. And if I look at the algebra, I factor out an x, and I get x minus 4. So my x-intercepts should be at 0 and 4. And this is an upward opening parabola, so something like that. And we're done.